Edsim++ Quick Start Tutorial. Edsim++ is an object-oriented visual pharmacokinetic pharmacodynamics modeling tool. Its elegant and innovative user interface makes the software extremely simple to use so that it is well suited for teaching pharmacokinetics. Edsim++ is equipped with a large number of advanced pharmacometric objects that can be used for building complex models as required in a research environment. Edsim++ employs the concept of object-oriented modeling. Pharmacokinetic and pharmacodynamic processes are represented by objects that can be dragged upon the desktop, after which the objects can be connected to each other. Double-clicking an object expands the Object Properties window, giving access to the details of the object. Objects are categorized into compartments: inputs, outputs, transfers, effects, and tools. All object parameters have default values so that a constructed model can be simulated directly without having to enter numerous parameter values first. Model parameters can be fitted to variable observations using the maximum a posteriori probability method developed by Bayes. Data can be easily imported or exported to Microsoft Excel. In this Edsim++ Quick Start tutorial, we will demonstrate how to build a basic pharmacokinetic model using Edsim++. We will use a TACROLIMUS model developed by Nastia Kassir as an example. The model was published in 2013 in the British Journal of Clinical Pharmacology. The Kassir model is a classic two-compartment model with an extravascular input. Edsim++ has ready-made templates for standard 1, 2 and 3 compartment models. Now please start Edsim++ by clicking the Edsim++ shortcut. From the application menu, select File, Open, Model. Select the file that is highlighted in the displayed image and click the Open button. This is a standard template for MWPHARM++ compatible two-compartment models. There are a number of objects in this model that are not required right now for our TACROLIMUS model. Therefore, we will first delete these objects. We must delete the intravascular input, because all model parameters are corrected for bioavailability. We must delete the intramuscular input, because we have no bioavailability for this particular route of administration. We must delete the renal elimination output because the Kassir model does not discriminate between renal and non-renal clearance. We must delete the hemodialysis output for the sake of simplicity. We must delete the objects representing the metabolic pathway, because it is not described by the Kassir model. The extended weighting object is also not necessary at this point. Double-click on one of the objects in order to view the Object Properties window. Drag the left window border to the left in order to expose more properties. Click the Parameters tab at the bottom of the Properties window. Check the All checkbox at the top of the Parameters section. Delete all scalar variables in the Allometry subsection using the Delete or Backspace key. Page 1056 of the Kassir paper describes the allometric scaling of the model parameters. All parameters, except absorption rate, are allometrically scaled to body weight using a reference value of 20 kg. Volume parameters V1 and V2 use an allometric exponent of 1.0. Clearance parameters CL and Q2 use an allometric exponent of 0.75. The allometric scaling reference value of 20 kg is set in the Variables tab of the patient object, while POP is checked. The allometric scalars are set to body weight in the Parameters tab, while all is checked. The format for all four parameters must be set to 2, and the exponents for CL and Q to 0.75. The population parameters of the model can be found in Table 4 of the Kassir paper. We are only interested in the parameter estimates of the pharmacokinetic parameters, between subject variability and residual variability. The parameter population values are entered in the Value column of the Parameters tab. The ST values are calculated from the coefficient of variation of the between subject variability, as shown in the displayed formula. The fit and base checkboxes are only checked for parameters with a known between subject variability. All parameters are assumed to be log distributed as indicated by the log checkbox. The residual error can be entered in two different places. In the assay error section of the plasma concentration variable named CO1.c, or in a special residual error object of type residual error. In this example, we will use the assay error. The assay error is represented as a third-degree polynomial function accepting the observed concentration as input parameter. The first term SD0 represents the additive error. The second term SD1 represents the proportional error. The Cassirer model only specifies the proportional error in percent. This value is entered as a fraction in Edsim++. Before we can execute a simulation, we must enter a dosage regimen. Remarkably, the Cassirer paper does not mention a dose at all. However, the dose for liver transplant patients is clearly stated in the ProGraph information sheet of the manufacturer. ProGraph is available in capsules containing 0.5, 1, and 5 mg tacrolimus. The recommended dose as capsules for pediatric liver transplant patients is 0.2 mg per kilogram per day. For patient of 20 kg, this amounts to 4 mg per day, divided into 2 doses of 2 mg. This dosage regimen can be entered in the Object tab associated with the absorption input object PO. The start time of the dose is entered in the T-null column. The duration of an administration is entered in the T-dur column. This only applies to infusions. The interval time is set in the TINT column. Finally, the total number doses is entered in the N-DOS column. One line represents one dosage regimen sequence. Multiple sequences can be entered. We will specify 20 doses, covering a period of 10 days. The therapeutic range is also contained in the ProGraph information sheet. For pediatric liver transplant patients, the range is 5 to 20 microgram per liter. This therapeutic range can be entered in the Variables tab associated with the reference object. Enter 5 microgram per liter in the min field, and 20 microgram per liter in the max field. We can now perform our first simulation. Click the play button in order to start the simulation of the 2 mg twice-a-day tacrolimus regimen. Edsim++ will automatically establish an appropriate end time for the simulation. However, you can explicitly set a simulation end time in the duration field of the simulation properties of the Sim tab. The default value of 0 means that Edsim++ will automatically establish the simulation end time. In this example, we will change this value to 400 hours and run the simulation again. One or more curves in the chart can be exported to an Edsim++ ECX file using the chart menu. Curves can be loaded back into a different chart at a later stage. Double-clicking the chart brings up the Chart Explorer window. Here you can customize the chart to your preferences. You can also export all raw data to Excel for even more control with respect to data visualization. Click Save As from the File menu and select the Excel file type. After the export has been completed, Excel will launch automatically. Raw simulation data can be accessed on the Sim sheet. Excel data can easily be imported into other data analysis software applications like Prism from GraphPad. The Meta tab in the DOSAGE plugin can be used for adding context information to the model. This will prepare the model for TDM applications using MWPHARM++. This screen also displays diagnostic information with respect to the compatibility of the model with other applications like MWPHARM++. It is clearly stated which actions must be taken in order to ensure compatibility. Finally, we will store the model into an Edsim++ EDX file. You should do this at regular time intervals while developing a model. Click Save As from the File menu, and select the EDX file type. The saved Edsim++ model can now be imported in MWPHARM++. MWPHARM++ is a specialized Edsim++ plugin, aimed at routine therapeutic drug monitoring and model-informed precision dosing. We refer to the MWPHARM++ Quick Start tutorial video for more details. This concludes the Edsim++ Quick Start tutorial. More information can be found on the website of MWPHARM. The headquarters of MWPHARM is in Prague, the beautiful capital of the Czech Republic. Thank you for your attention.